It takes about 300 days to travel to Mars from Earth, which means that a round trip takes a little less than 2 years. And while they're in space, it can take as long as 20 minutes for us to receive communication each way. And this is due to the fact that we can't send signals any faster than the speed of light, and they're super far away. So, I'm currently a student that is participating in a joint study that's taking place between NASA and UGA's computer science, engineering, and psychology departments. And the University of Georgia is doing some really tremendous work in making strides towards establishing some better teamwork and facilitating communication between astronauts and mission control during spaceflight. And so today I'm going to talk to you guys a little bit about what HERA is. We're going to talk about why we need HERA and what UGA is doing to help NASA complete their mission. So, HERA is an acronym that stands for Human Exploration Research Analog. And it's really just a 3-story simulation space capsule that is housed in a super huge warehouse in Houston. And currently they are on their 5th campaign and their 20th mission, which will end on September 30th of this year. So HERA has been in existence for a while, and it has held many hats over the years. And in its essence, what it's for is a simulation capsule for the isolation, the confinement, and the remote conditions that are experienced during space exploration. And what generally the protocol is to send 4 to 5 co-ed, sometimes not, astronauts into the capsule for 45 days, and they run a series of simulation-based studies. And during this time, they truly act like they are in space. They only interact with mission control. They can only speak to their families for 1 hour a week on Sundays. And they fully try to embrace the idea that they are in space. And they do a lot of different types of research, both while they're in the capsule and with the data that they gathered while they're in it. And some of these can be behavioral health, human factors, exploration of medical capability, and communication and autonomy. Communication and autonomy are really big for what is happening in HERA right now, due to the fact that we are in a communication crisis. And this communication crisis has been kind of ongoing for a while, and we're trying to figure out how to address it. One of our first encounters with this crisis was in 1999 with the unmanned Mars Climate Orbiter. And what happened in this incident is we spent millions and millions of dollars trying to build an orbiter to circle Mars so that it could gather data. And in an unfortunate miscommunication, one team used the metric system and one team used the imperial system. And so the intended path for the Mars orbiter actually was incorrect and ended up crashing it into the surface of Mars. And we're lucky that it was an unmanned mission and there were no fatalities. But what we realized is that when teams find themselves unable to work or communicate well, the results can be terrible, very expensive, and even fatal. And so, if we want to send real humans to Mars in an effort to colonize one day, we need to figure out how to avoid this in the future. As a result of this, NASA has begun researching teamwork and communication during super stressful long-term situations. Imagine cramped spaces, the same people every single day, very little communication with your family, and just being very far from home. It can be a very stressful environment. And so universities from all over the world are now collaborating with NASA and engaging in their own communication studies by interacting and recording data from the astronauts in HERA. So some of these universities are University of Houston, Northwestern University, University of Georgia, and each of us are doing kind of a different version of the same research, where at the end of all of our processes, we'll be able to create one big, research pie and give that to NASA. And what we're doing at the University of Georgia is called Project Red, and it is an interface that is being led by Dorothy Carter, who is a PhD student, a PhD graduate, who's now a doctor, from from Georgia Tech who got her PhD in organizational and industrial psychology. And her main focus is helping figure out how groups made up of astronauts and mission control staff and NASA scientists are most likely to react in any given situation. And we do this through Project Red, which is an interface that we use in experimental sessions, which consist of 4 HERA participants and 8 ground control or mission control undergraduate volunteers. Everyone is given a role, and for example, I am the mechanical engineer, and so they give me notes on what values I should expect as a mechanical engineer, and we go on this interface, and as a team, we try to build a well on Mars, and each of us have different bits and pieces of information, and we have to figure out how to work as a team in order to satisfy all of the requirements that each of our specific roles have. We can only do this through text-based conversation. There's nothing face-to-face, and every single time we meet, we actually have an increased delay in our communication. And so initially there was no delay, and in the second session there was a 1-minute delay, and in the third session there was a 3-minute delay, and so on and so forth. And so it gets much more difficult to actually accomplish goals as time goes on. And in Dr. Carter's words, we're helping NASA understand and diagnose their systems and predict what's most likely to happen. We're also providing interventions like training and debriefing approaches that could help remedy teamwork problems that are identified. And so, in conclusion, clearly the University of Georgia is making some really important contributions towards establishing better teamwork and facilitating communication in these really important space missions in the future. And today we spent some time